Question 49 from Chapter 2 homework. We haven't really started these calculations yet, but there was a question, so I'll get to that question. It was to calculate the number of silver atoms in a 0.5 kilogram sample. And before I get started, I just want to say be careful of this number because in this question, this number is a variable. So my number might be different than your number, but what's important is that the steps will be the same. Just our numbers will be a little bit different because of that. So I'm starting with a 0.5 kilogram sample of silver. So I've got 0.500 kilograms of silver, and our molar definitions are based on grams. So the first thing I want to do is to go from kilograms to grams. So I know in 1 kilogram I have 1,000 grams. So I have 500 grams of silver. And then from there, I want to go to the periodic table. And I go to the periodic table and I look up the atomic weight of silver. And silver is 107.87 grams per mole. So that's going to be my conversion factor to go from grams of silver to moles of silver. And then after I have moles of silver, I can find atoms of silver because I know Avogadro's number. So the next calculation, I have 500 grams of silver, and I know for every 107.87 grams of silver, I have 1 mole of silver, right? That came from the periodic table of the elements. So I have 4.635 moles of silver. The next conversion I need to know is that Avogadro's number tells me for every 1 mole, I'm going to have 6.022 e to the 23 atoms or molecules, depending on what we're talking about, right? So that's the next conversion to say, got 4.635 moles of silver, and I know for every 1 mole of silver, I need to have 6.022 e to the 23 atoms of silver. So moles of silver cancel out. I multiply by Avogadro's number, and I get 2.79 e to the 24 atoms of silver. 3 significant figures because the only thing that we have measured is the mass of the silver, and there are 3 significant figures in that number. 5.00 e to the negative 1 has 3 significant figures, so 3 significant figures in our final answer. As I said at the start, your number might be different, so check your mass. It might be slightly different. The other mistakes that I see when students do these questions is their formatting. So check the formatting in your calculation, especially with Avogadro's number. It's always a good idea to put anything in scientific notation in parentheses. That's a great way to help make sure it's interpreted accurately by your calculator. And don't worry if this question looks like a lot. We haven't covered this material yet. We'll cover this material Monday or Tuesday this week, depending on your lecture.